In this class, let us solve remaining problems of exercise 8.1. Question number 10th. Using binomial theorem, indicate which number is larger, 1.1 power 10,000 or 1000. Solution. So 1.1 power 10,000. So that is equals to 1.1. We can write 1.1 as 1 plus 0.1 whole power 10,000. Now let us expand this one 1 plus 0.1 power 10,000 by using binomial theorem. So we know that binomial theorem, that is a plus b power n is equals to nc0 a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square, so on. Last term is ncn b power n. So this is the binomial theorem for positive integer n. Now let us take a is equals to 1, b is equals to 0.1 and n is equals to 10,000. So if you take a is equals to 1, b is equals to 0.1, here index n is equals to 10,000, and we will use the formula NCR means n factorial by r factorial into n minus r factorial. So the value of 1.1 power 10,000, so that is same as 1 plus 0.1 power 10,000 is equals to NC0, n value is 10,000, so 10,000 C0 a power n, a value is 1, so 1 power 10,000 plus next term NC1, so that is 10,000 C1 a power n minus 1, so 1 power 10,000 minus 1, so that is 9,999 into b, b value is 0.1. So plus, so here since n is equals to 10,000, so if you expand what happens, there will be 10,000 plus 1 terms. So no need to write all those terms, as well as it is difficult to write all those terms. But if you see remaining terms, all terms will be positive. Since here n is positive, 1 is positive, as well as 0.1 is also positive. So remaining terms will be positive terms. So what we can write? Plus other positive terms. So that is equals to 10,000 C0. So what will get? 10,000 C0. So that is 10,000 factorial by 0 factorial into 10,000 minus 0 factorial. So 10,000 factorial will get cancelled, and 0 factorial is 1. So this value becomes 1. Again 1 power 10,000. So this value is also 1. So the value of this first term becomes 1 plus 10,000 C1. So what we will get? 10,000 C1. So if you use this formula, so that is 10,000 factorial by R value is 1 factorial into 10,000 minus 1. So that is 9,999 factorial. So 10,000 factorial, we can write it as 10,000 into 9,999 factorial. So these two will get cancelled. So the answer is 10,000. So this value becomes 10,000 into 1 power 9,999. So this value is 1. So what we can write? 10,000 into 0.1 plus other positive terms. So that is equals to 1 plus 10,000 into 0.1. So what we will get? This will be 1000 plus other positive terms. So 1000 plus 1 becomes 1001 plus positive terms. So 1001 plus positive terms means obviously what happens? It is more than 1000. So 1.1 power 10,000 value is what? More than 1000. So that is more than 1000. So what we can conclude? We can conclude that 1.1 power 10,000 is larger than 1000. So like this, binomial theorem can be used to compare two numbers, which one is larger, which one is smaller, like this. So these type of numbers, we cannot directly find the value of 1.1 power 10,000 by multiplication because it is very lengthy process. So we can apply binomial theorem and we can compare these type of numbers. Next question. Question number 11. Find a plus b power 4 minus a minus b power 4. Hence evaluate root 3 plus root 2 whole power 4 minus root 3 minus root 2 whole power 4. Solution. So first we have to simplify this term a plus b power 4 minus a minus b power 4 by using binomial theorem. After that we have to evaluate that value. So we know that from binomial theorem a plus b power n is equals to nc0 a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square, so on. Last term is ncn b power n. Now consider a plus b power 4 minus a minus b power 4. So that is a plus b power 4 minus a minus b power 4. So that is equals to a plus b power 4. So if you expand by using binomial theorem, so here n value becomes 4. So what we can write? If you expand by taking n is equals to 4, 4c0 a power 4 plus 4c1 a power 4 minus 1, that is a cube b plus 4c2 a square b square plus 4c3 a b cube plus 4c4 b power 4. So this is the expansion of a plus b power 4 minus we have a minus b power 4. So again we will use the binomial theorem, but in place of b what we have to take here, minus b, and n value is 4. So what we will get again, 4c0 a power 4 plus 4c1 a cube minus b plus 4c2 a square minus b square plus 4c3 a minus b cube plus 4c4 minus b power 4. Now if you simplify this one, see here 4c0 a power 4 minus 4c0 a power 4 means we can cancel these two terms. Here 4c1 a cube b, here what we will get, minus into minus plus, so means same term. So what we can write, 2 times 4c1 a cube b. If you see this term, minus b whole square means that is plus b square. So 4c2 a square b square minus 4c2 a square b square. So again we can cancel these two terms. Again here minus b whole cube means minus. So minus into minus plus. So we have to add these two terms. Next term here minus b power 4. So that is same as b power 4. So what we will get, 4c4 b power 4 minus 4c4 b power 4 means these two terms again will get cancelled. So that is equals to, so what we can write, see here 4c1 a cube b minus minus plus 4c1 a cube b. So I can write it as 2 times 4c1 a cube b. Similarly here 4c3 a b cube minus into minus plus 4c3 a b cube. So that is 2 times. So I have already took 2 outside plus I can write it as 4c3 a b cube. So that is equals to 2 times. So what we'll get, 4c1. 4c1 value is 4 factorial by 1 factorial into 4 minus 1 factorial. So what we'll get, 4 factorial by 3 factorial, that is 4 a cube b plus 4c3. So this value is also, if you simplify what we'll get 4. That is 4 factorial by 3 factorial into 1 factorial. So 3 factorial will get cancelled. That is 4 into a b cube. So if you want, you can take 4 outside. So what we will get, 8 times a cube b plus a b cube. So if you expand this one, a plus b power 4 minus a minus b power 4. So you will get how much? 8 times a cube b plus a b cube. Now we have to evaluate this value. So that is root 3 plus root 2 power 4 minus root 3 minus root 2 power 4. So if you see these two expressions, both are same. This is equals to this one. Whenever we take a is equals to root 3 and b is equals to root 2. If you take a is equals to this much, b is equals to this much, both will be same. So to evaluate this one, so what we can take in place of a, we can take root 3 and in place of b, we can take root 2. So if you simplify, we got this much, that is 8 times a cube. A value is how much here? Root 3 whole cube into b. B value is root 2 plus a means root 3 into b cube. B cube means root 2 whole cube. So that is equals to 8 times root 3 whole cube. So that is equals to 3 into root 3, this into root 2 plus root 3 into root 2 whole cube. So what will get? Root 2 whole cube. So that is root 2 into root 2 into root 2. So we can write it as 2 into root 2. So that is equals to 8 into here. What we can write? 3 into root 6 plus here 2 into root 6. So that is 3 plus 2, 5. 5 root 6. 5 into 8. So that is 40 root 6. So if you expand this expression, you will get 40 root 6. So similarly, you can solve the question number 12. So it is similar to question number 11. So now question number 13. Show that 9 power n plus 1 minus 8n minus 9 is divisible by 64 for positive integer, where n is a positive integer. Solution. Suppose if you consider two numbers a and b, then we can say that a is divisible by b. If we can write a is equals to some b into k, where k is any integer. Suppose if we can write a is equals to b into k, then what we can say? We can say that b divides a. So similarly, here what we have to show, 9 power n plus 1 minus 8n minus 9 is divisible by 64. Suppose if we can write 9 power n plus 1 minus 8n minus 9 is equals to 64 into k, where k is any natural number, then what we can conclude? We can conclude that this is divisible by 64. Now we know that binomial theorem, a plus b power n is equals to nc0 a power n plus nc1 a power n minus 1 b plus nc2 a power n minus 2 b square, so on. Last term is ncn b power n. Suppose consider the expansion of 1 plus a power n plus 1. So in this expansion only, in place of a we are taking 1. In place of b, if we take a, in place of n, if we take n plus 1. So what we can write here, this expansion becomes, in place of n what we have, n plus 1. So n plus 1 C0 a power n. But in place of a what we have, 1 power n is 1. Plus next term, in place of n we have to take n plus 1. So n plus 1 C1. So 1 power anything is 1. So what we will get here, 1 power n minus 1 is also 1 into b. B means what? A. So plus n plus 1 C2. Here 1 power n minus 2 is 1 into a square. Plus so on. Last term is what? N plus 1 C n plus 1 b. B means what? A power n plus 1. So this is the expansion of 1 plus a power n plus 1. So just we are modifying the binomial theorem by taking a is equals to 1, b is equals to a, n by n plus 1. Now suppose if I take a is equals to 8. So in this expansion, if I take a is equals to 8. So what I can write, LHS becomes 1 plus 8 power n plus 1 is equals to RHS. RHS will be n plus 1 C0 plus n plus 1 C1. A value is how much? 8 plus next term n plus 1 C2. A means 8 square. So on. Last term is n plus 1 C n plus 1. A means 8 power n plus 1. So that is 1 plus 8. 1 plus 8 is 9. 9 power n plus 1 is equals to n plus 1 C0. If you simplify this one by using the formula NCR. NCR means n factorial by r factorial into n minus r factorial. So what we will get, n plus 1 factorial by 0 factorial into n plus 1 factorial. So n plus 1 factorial, n plus 1 factorial will get cancelled. So this value becomes 1 plus n plus 1 C1. So this value becomes how much? N plus 1 factorial by 1 factorial into n plus 1 minus 1. So that is n plus 1 factorial by n factorial. So n factorial we can cancel. So this value becomes n plus 1 into 8 plus see from next terms onwards. Here what we have, 8 square, next 8 cube, 8 power 4, so on 8 power n plus 1. From the remaining terms, so we can take 8 square as common. Suppose if I take 8 square as common, so what I will get here, n plus 1 C2, already I have to 8 square as common. So on, from each term I will take 8 square as common. So last term n plus 1 C n plus 1. So if I take 8 square outside, so what I will get, 8 power n minus 1. So simplify, 9 power n plus 1 is equals to here. What I can write, 1 plus 8n plus 8. So 1 plus 8 becomes 9 plus 8n. So if you simplify this one, what I will get, 9 plus 8n plus here 8 square means 64. 64 into these terms. So if you see, all terms are what? All terms are positive here. Here what we'll get here? N plus 1 C2. This is positive. If you find all the values, it will be positive. Again, powers of 8. That is also positive quantity. So this quantity will be positive. So what I can take in place of this one, I will take k, where k is equals to how much? N plus 1 C2, so on, remaining terms till n plus 1 C n plus 1 8 power n minus 1. Now take these two terms to LHS. So 9 power n plus 1 minus 8n minus 9 is equals to 64k. Where k is what? K is some natural number. So we have seen if 9 power n plus 1 minus 8n minus 9, if it possible to express like this 64 into k, where k is natural number. So what we can conclude? We can conclude that this quantity, that is 9 power n plus 1 minus 8n minus 9, is divisible by 64. So what we can conclude? We can conclude that 9 power n plus 1 minus 8n minus 9 is divisible by 64. Question number 14. Prove that summation r is equals to 0 to n 3 power r NCR is equals to 4 power n. So solution. So we have to prove that the value of this summation r is equals to 0 to n 3 power r NCR is equals to 4 power n. So consider this one. Summation of r is equals to 0 to n 3 power r NCR. Suppose if we expand this expansion, that is summation, by giving values from r is equals to 0 to n. Suppose if we give r is equals to 0, what will we get? 3 power 0 NC0. If we give r is equals to 1, 3 power 1 NC1 plus r is equals to 2 means 3 square NC2, so on. Last term is when r is equals to n. So what we will get? 3 power n NCn. So consider it as equation 1. Now we know the binomial expansion, that is a plus b power n is equals to NC0 a power n plus NC1 a power n minus 1 b NC2 a power n minus 2 b square, so on. Last term is NCn b power n. Suppose if I take a is equals to 1, b is equals to a, then the expansion 1 plus a power n. Here I am taking a is equals to 1, b is equals to a. So what I will get? NC0, see here, 1 power n, 1 power n is 1, plus NC1, 1 power n minus 1, that is 1 into b. In place of b, what we have? A plus nc2 1 power n minus 2, that is 1. b means a here. So a square. So last term ncn. So what I will get? A power n. So if you want, you can consider this as equation 2. So this expansion we have obtained from binomial theorem by taking a is equals to 1, b is equals to a. So if you compare equation 1 and 2, if you compare equation 1 and 2, right hand side. So right hand side of equation 1 and 2, what I will get? It seems both are same. So 3 power 0 is 1. See here, nc0, here also nc0, nc1, nc1, a 3. So suppose if I take a is equals to 3 in equation 2, so what we can conclude? We can conclude that equation 1 and 2 are same in the right hand side. So if the equation 1 and 2 are same, RHS of equation 1 and 2 are same means what we can conclude? LHS also same. So we have to a is equals to 3, then these two are equal. So LHS also same when I take a is equals to 3. So substitute a is equals to 3. So what we can write? Summation of r is equals to 0 to n 3 power r into ncr, that should be same as 1 plus a power n, but I took a is equals to 3 here. So what I will get? 1 plus 3 power n, that is 4 power n. So we obtained summation of r is equals to 0 to n 3 power r ncr is equals to 4 power n. So thank you.